In the last class, we are discussing about uniform circular motion. What does it mean by uniform circular motion? When a body moves over a circular path and takes equal time for each revolution, then the motion of the body is said to be uniform circular motion. As I have already told you, in uniform circular motion, the speed of the body remains constant, but the velocity of the body changes from point to point, because velocity is directed along the tangent and direction of tangent to the circular path changes from point to point. Therefore, magnitude of velocity, that is speed, remains constant, but velocity is a variable. Therefore, uniform circular, in case of uniform circular motion, there is an acceleration, and the direction of acceleration we have already discussed. The direction of acceleration is toward the center of the circular path. Therefore, this acceleration is called central acceleration. Up to this we have discussed in last class. So, in uniform circular motion, there is an acceleration, and the direction of acceleration is directed toward the center of the circular path. Today we shall find out the magnitude of central acceleration. After finding out the magnitude of central acceleration, we can find out what is the force acting on the body, the force which is called centripetal force. So, let us find out magnitude of central acceleration. Magnitude of central acceleration. Central acceleration. Magnitude of central acceleration. How much what is the value of central acceleration? Actually, the change of velocity per second, that we will find out. So, let us take a circular path. Center of the circular path is O. At the point A, the velocity, suppose the velocity is V. At the point B, suppose the velocity is V plus delta V. V plus delta V. Angular displacement from A to B is delta theta. Radius of the circular path is R. So, we have considered a circular motion. The body is moving over a circular path. The center of the circular path is O. Radius of the circular path is R. Velocity of the body at A is V. Velocity of the body at V plus delta V. So, when the body moves from A to B, change in velocity is delta V. Suppose the time taken by the body to go from A to B is delta t. Velocity at A is equal to V. Velocity at B is equal to V plus delta V. So, change in velocity is V plus delta V minus V, that is delta V. As the body goes from A to B, change in velocity delta V. Time taken to go from A to B is suppose delta t. Time taken. Angular displacement, angle covered by the body during this time. Angular displacement of the body is equal to how much? Delta theta. That is the angle is AOB. Angle AOB, that is delta theta. So, what will be the acceleration of the body? Change in velocity delta V. Time taken for the change delta t. So, acceleration of the body is how much? Acceleration is equal to limit delta t tending to 0, delta V by delta t. Acceleration is equal to limit delta t tending to delta V by t. We will find out the expression for this delta V by delta t. How much is that? So, let us consider a vector triangle. Which is the vector triangle? The vector triangle is, let us consider a vector triangle AOB. Let us consider a vector triangle AOB. Side OA is V, side OB is V plus delta V, vector AB is what? Delta V. So, let us consider a vector triangle OAB. OA is V, OB is V plus delta V, AB is delta V. From triangle of vector addition, OA vector plus AB vector is equal to OB vector. So, OA is equal to what? V plus AB is equal to V plus delta V. So, your AB vector becomes equal to how much? Delta V. AB vector becomes equal to delta V. So, what is the acceleration? So, acceleration is equal to how much? Limit delta t tending to 0. In place of delta V, let us put AB. AB by delta t. AB by delta t. Acceleration is AB by delta t. Now, we will find out expression for AB by delta t. Then we will find out, we can know what is the acceleration. So, now since the body takes a very small time to go from A to B, AB can be considered to be a straight line. So, AOB can be considered to be a triangle. Since A and B are very close, A and B are very close, AB can be considered to be a straight line. AB can be considered to be a straight line. AB can be considered to be a straight line. So, triangle, so OAB can be considered to be a triangle, can be considered to be a triangle. AOB can be considered to be a triangle. Now, let us consider the two triangles AOB and O small a small b. The triangles OAB and O small a small b are similar. Why they are similar? Because we have taken the velocity at A as one side OA, velocity at B as another side OB. So, the two triangles are now similar. This angle is also delta theta. Triangles are similar. Therefore, AB by small ab is equal to OA by small oa. When the triangles are similar, the sides are proportional. So, AB by small ab is equal to OA by small oa. So, AB is equal to how much now? AB into OA by OA. AB is equal to AB, capital AB into small oa by OA. AB into capital small oa, V, capital OA, radius of the circular path R. AB into V by R, small ab. Now, as you know delta theta, you know from the arc, delta theta is equal to how much? AB by OA. So, AB is equal to how much? AB is equal to how much? OA into delta theta, because theta is equal to L by R, concept of arc. Delta theta is AB by OA. So, AB is equal to OA into delta theta. What is OA? R into delta theta. Now, let us put the value of AB here. So, small ab is equal to how much? R into delta theta into V by R. That is equal to how much? R cancels, V into delta theta. So, AB is equal to V into delta theta. Now, put the value of AB in the expression for acceleration. Hence, acceleration is equal to how much? Limit delta t tending to 0, AB V into delta theta by what? Delta t. Limit delta t tending to 0, V into delta theta by delta t. That is V taken outside, limit delta t tending to 0, delta theta by delta t, that delta theta by delta t, angle covered by time taken, that is equal to v into omega. What is omega? Omega is angular velocity. Omega is uniform angular velocity. Uniform angular velocity. Omega is uniform angular velocity. So your acceleration is, acceleration is equal to how much? Acceleration is v into omega. As you already know that v into omega is what? V by r. This is already proved. V, therefore acceleration is how much? V square by r. So what is the magnitude of central acceleration? Magnitude of central acceleration is v square by r. Magnitude of central acceleration, magnitude of central acceleration is equal to v square by r. So when a body moves over a circular path with a speed v and radius of the circular path r, there is an acceleration of the body. The magnitude of the acceleration is v square by r, and direction of acceleration is toward the center of the circular path. So this acceleration is called central acceleration or centripetal acceleration. Central acceleration or centripetal acceleration, that is center seeking acceleration. So acceleration is v square by r. If m is the mass of the body, if m is the mass of the body, m is equal to mass of the body, force acting on the body is how much? Force acting on the body. What is the force? Force is equal to mass into acceleration, F. F is equal to how much? Mass into acceleration. Mass into acceleration. M, acceleration is v square by r. So this is the force acting on the body. So F is equal to how much? mv square by r. This force is called centripetal force. F is equal to mv square by r. This force is called, centripetal force. Centripetal force or center seeking force. Centripetal force or center, this force is called centripetal force or center seeking force. So when a body moves over a circular path with a speed v and radius of the circular path r, mass of the body is m, there is a force acting on the body. The magnitude of the force is mv square by r, and direction of force is directed towards the center of the circular path. This force is called centripetal force or center seeking force. So when there is a force acting on the body towards the center of the circular path, there was a force directed away from the center of the circular path. That force is called centrifugal force. Centrifugal force. What is the magnitude of centrifugal force? Magnitude of centrifugal force is mv square by r. It is directed away from the center of the circular path. Magnitude of centrifugal force, magnitude of centrifugal force is mv square by r. Same magnitude. What is direction? It is directed away from the center of the circular path. It is directed away from the center of the circular path. From the center of the circular path. This acts at the center of the circular path. This direct away from the center of the and acts at the center of the circular path. We can experience centrifugal force. Suppose you tie a stone and wheel it in a hand, you will feel a force acting at the tip of the finger as if the tip of the finger is pulled away. So, that pulling force which is pulling away your tip of the finger is called centrifugal force, which always try to fly away the body. So, this is directly out from the center of the circular path. So, this centripetal force is a very important question for the examination. In the examination, question comes, what is centripetal force? Find out an expression for centripetal force. You will first define what is a centripetal force. How to define the centripetal force? When a body of mass m moves with a speed v uniformly over a circular path of radius r, a force of magnitude mv square by r acts on the body, and direction of this force is directed toward the center of the circular path. This force is called centripetal force or center seeking force. Then find out the magnitude of that centripetal force, as I will deduce it. This is a very important question in the examination. Centripetal force. Expression for centripetal force, expression for centripetal force. Expression for centripetal force in terms of frequency of revolution, frequency of revolution. In terms of frequency of revolution, expression for centripetal force in terms of frequency of revolution. We will find out, we have already found out the expression for centripetal force, that is F is equal to mv square by r. Now, we will find it out in form of frequency of revolution. What does it mean by frequency? What is number of revolutions made by the body per second. How to find out? F is equal to how much? mv square by r. M is mass of the body, v is velocity, speed of the body, and r is radius of the circular path. As you already know, v is equal to how much? 2 pi r by t. 2 pi r by t. What is t? Where t is time period of revolution. What does it mean by time period of revolution? Time taken by the body to make one complete revolution, the time period of revolution, that is equal to 2 pi r by t. Now, that is equal to how much? 2 pi r into 1, in place of 1 by t, we can write n. What is n? N is frequency, where n is frequency. Where n is frequency. Now, we can put the value of v here. F is equal to how much? mv square by r into v is equal to mv square by r, that is equal to m by r. In place of v square, you can let us put 2 pi r n whole square, 2 pi r n whole square, that is equal to how much? M into 4 pi square r square n square by r, that is F is equal to how much? 4 pi square m r n square, 4 pi square m r n square. This is expression for centripetal force in form of frequency of revolution. Now, let us discuss about banking of track. Banking of track. Banking of track. Banking of track. What does it mean? What is the meaning of banking of track? What is banking? What is banking? When you see a car road, you mark that the outer side of the car road is elevated, raised to some extent with respect to the inner side. That means the road is curved, curved road is sloped toward the center. This is known as banking of track. You can very well mark it in some railway line where there is a curve, the outer rail is raised to some extent with respect to the inner rail. So, what is banking? What is banking? What is banking of track by banking of road? What is banking of road? It is seen that the outer side of the car road is raised to some extent with respect to the inner side, that the car road is sloped toward the center. It is seen that the outer side of a car road is raised to some extent with respect to the inner side. It is seen that the outer side of a car road is raised to some extent with respect to the inner side. That is, the car road is sloped, toward the center, car road is toward the center. This phenomenon is called banking of track or banking of road. This phenomenon is called banking of road. Outer side is raised to some extent with respect to the inner side. This is known as banking of road. Now, why this banking is made? Before discussing the necessity of banking, let us go to the motion on an unbanked curve when the road is not banked. Motion on an unbanked curve. Unbanked car road. What is the difficulty there? So, from that difficulty we will go to necessity of banking. Why the roads are banked? You first go to an unbanked road. What difficulty you are facing there? To overcome that difficulty, we will bank the road. So, motion on an unbanked road. What is the meaning of unbanked car road? The road is curved, and but both the sides of the car road are at the same level. That is unbanked curve, like this. Both the road is not curved, both the sides of the road are at the same level. Like this. Unbanked curve means both the sides of the road at the same level. In case of an unbanked road, unbanked car road, both the sides, both the inner and outer side of the road are at the same level. The outer side is not raised with respect to the inner side. Both are at the same level. So, what difficulty is here? Let us see. So, to surmount that difficulty, we will go for banking. That is called necessity of banking. So, what happens here? Now, suppose the road is here. Suppose mass of the automobile is equal to m. So, what is weight? Weight of the automobile is equal to how much? mg. Weight of the automobile is mg. As you know, weight always acts vertically downwards. Weight is acting vertically downwards. So, what is the reaction of the ground? reaction of the ground is equal to capital R, that is equal to mg. Reaction of the ground is equal to capital R, that is equal to mg. This is your reaction of the ground R in vertically upward direction. Then what is the force of friction here? What is the force of friction? If F is the force of friction between the automobile and the road, between the automobile and the road means between the tires of the automobile and the road, that is equal to F is the force of friction between the automobile and the road. Then F is equal to how much? Mu r. F is equal to mu r. What is mu? Coefficient of friction, where mu is coefficient of friction. Mu is coefficient of friction. Mu is coefficient of friction. So, what is force of friction? Force of friction is how much? Mu mg. This is your force of friction. So, for the safe running of the automobile, this force of friction must be equal to centripetal force. For safe running of the automobile along the car road, for safe running of the automobile, for safe running of the automobile on the car road, the force of friction provides necessary centripetal force for circular motion, for centripetal force, that is F is equal to mu mg, that is equal to what? mv square by r, where r is the radius of the car road. Mu mg mv square by r. V is what? Velocity of the automobile, and r is radius of the car road, So, F mu mg is equal to mv square by r. So, V square is equal to how much? Mu rg. So, V is equal to how much? Mu rg root over. So, this is the velocity along an unbanked curve. Velocity on an unbanked car road. V is equal to mu rg root over, velocity on an unbanked car road. As you know that the automobiles, they fly with very high velocity. So, for that purpose, for the velocity to get high, mu is to be increased. Coefficient of friction between road and the automobile must be increased. Frictional force must be increased. So, when the frictional force is increased, there will be lot of wear and tear. The automobile will be damaged. So, for V to be large, mu must be large, mu must be more, mu must be increased, mu must be large or mu must be increased, But when mu is increased, there will be lot of wear and tear. But when mu is increased, there will be lot of wear and tear, lot of wear and tear, lot of energy will be spent, wear and tear, lot of energy will be spent, lot of energy will be spent, energy will be spent. So, in order to avoid it, roads are banked. That is, this is the necessity of banking. In order to avoid it, car roads are banked. Car roads are banked. Car roads are banked. Car roads are banked. This is the necessity of banking. This is the necessity of banking. This is the necessity of banking. So, now let us see the banking of road and what is the velocity along a banked road. So, in case of unbanked road, what is to be done? For the automobile to fly with high velocity, coefficient of friction between the automobile and the road should be increased. So, in that case, lot of energy will be spent. So, to avoid it, roads are banked. Banking of track. Motion on a banked car road. Banked car road. Motion on a banked car road. So, let us see a bank. The outer side of the road is red to some extent in comparison to the inner side, like this. The automobile is now here. Automobile is here. What is the angle of banking? Angle of banking is theta. Theta is the angle of banking. Here the angle of banking is theta. Angle of banking is theta. So, the automobile, mass of the automobile is m. Velocity of the automobile is v. Radius of the car road is smaller. Radius of the car road is smaller. So, what is the reaction of the ground? The reaction of the ground is like this now, because the automobile is now in tilted position. It is not on the road is not plane on both the sides. The outer side is raised to some extent. Therefore, the automobile is in tilted position. So, this is the reaction of the ground. Reaction of the ground is capital R. Now, this reaction can be resolved into two components. One. This is r cos theta, this angle is theta, this is r sin theta, r cos theta, r sin theta. Weight is how much? mg. This is how the automobile is placed on the road. Reaction of the ground is r. Theta is the angle of banking. So, r can be resolved into two components. R is resolved into two mutually perpendicular components. mutually perpendicular components. The vertical component is r cos theta. The vertical component r cos theta, horizontal component r sin theta. In equilibrium position, what happens? R cos theta is equal to weight of the automobile which acts vertically downwards. R cos theta is equal to how much? mg, that is equal to weight of the automobile. Weight of the automobile. And r sin theta provides the necessary centripetal force for circular motion. R sin theta is equal to what? Centripetal force. That is equal to how much? mv square by r. R sin theta is equal to centripetal force, that is equal to mv square by r. So, r cos theta is equal to mg, weight of the automobile. R sin theta is centripetal force, that is mv square by r. So, r sin theta by r cos theta is equal to how much? mv square by r by mg. So, your tan theta is equal to how much? Tan theta cancels, v square by rg, or theta is equal to how much? Tan inverse v square by rg. This is expression for angle of banking. The road is banked at this angle. So, theta is equal to tan inverse v square by rg. This is your angle of banking. So, what is done? When the automobile moves on the car road, the road is already banked, the angle is already met. The automobile is not going to make the angle. When you move on a cycle on the car road, you make the angle, you turn your body toward the car right, but when in this case the road is already banked, angle is already met, radius of the car road is already there. So, how to maintain this condition? Tan theta is equal to v square by rg. So, the only option with the driver is that he has to control the velocity or speed of the automobile. So, with the driver which is left, v is left to the driver. So, velocity is to be controlled. So, that this condition is maintained, tan theta is equal to v square by rg. So, therefore, it is always advisable to cross a car road with very less velocity. Velocity should be less when the driver is crossing the car road, otherwise there will be skidding of the automobile. Normally, short questions also come from centripetal force, circular motion. What is the work? Very important short question is what is the work done by centripetal force? 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 How much work is done by centripetal force? What is work done? As you know, work is force dot displacement. Force is F, S is the displacement. So, work is equal to what? W is equal to what? F dot S, that is Fs cos theta. F is the force and S is the displacement. Theta is the angle between force and displacement. So, what is in this case, what is the direction of force and what is the direction of displacement? In case of circular motion, the direction of centripetal force is toward the center and direction of displacement is along the tangent. In case of circular motion, direction of force is towards the center of the circular path, In case of circular motion, direction of force is towards the center of the circular path. The direction of displacement is along the tangent, because if you move a body in a circular path, the body will fly off along the tangential direction. So, direction of displacement is along the tangent and direction of force is along toward the center, that is along the radius. So, what is the angle between force and displacement? Angle between force and displacement is 90 degree. So, angle between force and displacement is 90 degree. When the angle between force and displacement is 90 degree, what is the work done? So, work done is equal to Fs cos theta, that is equal to Fs cos 90. What is cos 90? Cos 90 is 0. So, work done is equal to 0. So, no work is done by centripetal force. Therefore, no work is done by centripetal force. No work is done by centripetal force. Remember this, no work is done by centripetal force. You may get also problems to calculate centripetal force. Suppose a body is moving in a circular path of radius is given, mass of the body is given and velocity of the body is given. Calculate the centripetal force acting on the body. You may get numericals like that, very simple numericals. Suppose a body of mass 10 grams is moving on a circular path of diameter 8 centimeter with a speed of, very simple question, with a speed of 10 meters per second. Simple question, 10 meters per second. Calculate the centripetal force. Acting on the body. Calculate the centripetal force acting on the body. So, suppose this question comes in the examination. Normally, this type of problems they come in the plus 2 examination, simple problems. Suppose a body of mass 10 grams is moving on a circular path of diameter 8 centimeter with a speed of 10 meters per second. Calculate the centripetal force acting on the body. So, when you see a problem, first see what is to be found out. Here we have to find out the centripetal force. So, what is the expression for centripetal force? F is equal to how much? mv square by r. See what are given to you. You want to find out the centripetal force. The formula for centripetal force is mv square by r. When we write the expression for centripetal force, you get some mass. F is equal to mv square by r, you get some mass. If you put this formula in the answer book, you get some mass. 0.5 mass, like that. After 2 mass, you can get 0.5 mass. mv square by r. Now, you see what are the data given. We are provided with what? Mass of the body m is given c. What are the data given? Data m is equal to how much? 10 grams. V is equal to how much? 10 meters per second. R is equal to diameter D 8 centimeter. So, radius is equal to how much? 4 centimeter. So, m is given, V is given, R is given. So, all the things are given. So, you can calculate, but see that whether all the things are given in the same system of unit or not. That is the most important part or a vital part of solving a problem. Normally 70% of the students, they commit this mistake. They write the formula, put the data, but the data not in the same system of units. Data not in the same system of units. Data, all the data must be in the same system of units. Same system of units means mass is given 10 gram CGS unit, velocity is given 10 centimeter per second CGS unit, radius is 4 centimeter, velocity is given 10 meters per second in the MKS unit, radius is 4 centimeter in CGS unit. Now, you see whether you want to solve the problem in MKS system or in CGS system. If you want to solve the problem in CGS system, convert all the data to CGS system. If you want to solve the problem in MKS system, convert all the data to MKS system. It is left to you, which is convenient to you, whether you want to convert to CGS system or you want to do it in MKS system. So, m is 10 grams, let us do it. In m is 10 grams, 10 meters per second, r centimeter. It is since two things are given in the CGS system, one is given in MKS system, it is better to solve in CGS system. So, m is equal to, we can put m is equal to 10 grams, velocity 10 meters per second. So, let us convert it to what? 10 meters per second, it will convert it to centimeters per second. That is equal to how much? Tell me. 10, this is into 100, that is 1000 centimeters per second, 1000 centimeter per second, and radius is how much? 4 centimeter. Now, we can put the data like now. F is equal to how much? m v square by r. M is equal to 10 v square by r, 4 m v square by r. This is what? This much dynes, because we have taken in CGS system this much dynes. So, that is equal to how much? 1 by 4 into 10 to the power how much? 10 to the power 7 dynes. 1 by 4 into 10 to the power 7 dynes. If you do in CGS system, this is in CGS system. Same problem can be done in MKS system also, but in the examination, not doing both the system, it is left to you. So, MKS system, if you solve, somebody solves in MKS system, what is to be done? M 10 grams. That is how much kg? 10 by how much? 10 by 1000 kg. Velocity 10 meters per second. Radius 4 centimeter, that is equal to 4 by what? 4 by 100 meter. Now, you can put the values here. When you are putting the data, all the data must be the same system of unit. That is the vital part of solving a problem. Most of the students, around 70% of the students, they commit this mistake in the examination. They do not put the same data in the same system of unit. That is F is equal to how much? M v square by r. M is how much? 10 by 1000. V square 10 into 10 by r, 4 into 100. 4 into 100. This much what? Unit now becomes what? This much newtons. That was dynes, here it will be newtons. So, how much? 10, 10, 10. This will cancel. So, this becomes 1 by 4 into 100 newtons. 100 newtons. That is 25 newtons. Here also you can write 1 by 4, that is 25 in 10 to the 5 dynes, 25 in 10 to the 5 dynes, and you know that 1 Newton is 10 to the 5 dynes. So, 25 10 to the 5 dynes, here it becomes how much? 25 Newton. So, this is what your uniform circular motion. You can get long question, you can get short question, you can get numerical also from this chapter. The very important chapter. The important long question is define centripetal force and deduce an expression for centripetal force. So, first of all write the definition of centripetal force and deduce the expression F is equal to b square by r. Then there can be number of short questions from this, and also you can get numericals. So, when you are solving numericals are not difficult at all. But students, when they see the numericals, they get frightened and do not solve, but they are very easy. If you develop the art of solving numericals, physics will be very easy and you can secure very high marks. So, this is all about this chapter, uniform circular motion. Clear? It is all right. Thank you very much.